In this video, I'll be showing how to create and utilize a generic structure. The structure I'm going to be creating will represent a conveyor belt, and essentially it's just a wrapper around a vector, but we only want certain items to exist on the conveyor belt, so we're going to use a trait in order to do that. So conveyor belts, they have certain dimensions that they can accommodate, so we're going to create a dimension struct. The dimension struct will have a width, height, and depth. Now that we have our dimension structure, we're going to create a trait. So this will be the trait that any objects that go on the conveyor belt will need to implement in order to be placed on the conveyor belt. The trait will have two functions. It will have a weight function, which will return the weight of the item, and it will also have a dimensions function. The dimensions function will just return the dimensions of the item that's being conveyed. The next thing we're going to do is create our conveyor belt structure. So we'll just call it conveyor belt. And it's going to have some items, and the items will just be a generic vector. Now what we need to do with this conveyor belt structure is add a generic constraint. So we have a generic type T, and we're going to constrain it to our convey trait. So what we're doing here is we're telling Rust that we have a conveyor belt. It has some kind of generic parameter within, and that generic parameter must implement the convey trait. Our convey trait is here, and so anything implementing convey will have a weight function and a dimensions function. Normally, with a generic vector, we would be able to place any kind of items within it. However, our generic constraint here restricts this vector to just items that implement the convey trait. I'm also going to be creating a generic implementation for our conveyor belt. So the generic implementation will allow us to add items to the conveyor belt. We'll only have one function. We'll call it add. It'll take a mutable reference to self, and it will have the item that we need to add. We'll then do self.items.push, and we'll just push the item onto the conveyor belt. If you recall, the push method is just defined on a vector, so there's nothing special going on in here. There's a few implementation details we need to add to our implementation block in order to be able to use it with our generic structure. We have our generic type T here, but we haven't created our constraints yet. So let's do that now. After the IMPL keyword, we'll create our generic type T, and we'll make it generic over the convey type. Then after the conveyor belt structure name, we'll just put a T. What we're doing here is we're implementing a conveyor belt, and the conveyor belt is generic over type T, and that type T must implement the convey trait. The next thing we need is something to put onto our conveyor belt. So I'm going to paste in some code that I have. We have a car part, and it has the necessary information to be conveyed. We have some dimensions here, we have a weight, and a part number is just specific to this car part. I'm also going to implement a default implementation for car part. So here's some code that I've pasted in. So I'm implementing default for car part, and it's just going to create a new car part with some default information. That's what we'll use later when we go to create the car part. The last thing we need to do for the car part is implement our convey trait. So I'm going to bring the convey trait down here to the car part, so that way we have it for reference. So I'll implement this trait. So we'll implement convey for car part. So we'll do the weight function. And that's just going to return the weight of the car part. And we'll also do the dimensions function. We'll create a new dimensions since our car part doesn't actually have this field. The fields in our car part are all just in the structure. So we have width, height, and depth separately, but our trait requires that we return an actual dimensions structure. So we're just going to build one here and return it. Now that we've implemented our convey trait for the car part, we can utilize it in a program. So I'm going to go hop down to the main function. And within our main function, I'll create a new conveyor belt. So I'll just call it belt. and it'll be a new conveyor belt. And the items will just be an empty vector. So right now there's nothing on the conveyor belt. Next, I'm going to add a car part to the conveyor belt. We'll just make a default one. Once we call the add function to add the car part to the conveyor belt, this conveyor belt actually becomes specific to car parts. So if we wanted to take a look at the type of this conveyor belt, it's actually a conveyor belt of type car part. So if we had different structures that also implemented our convey trait, we would not be able to add it to this specific belt because this one is now just for car parts. But that's okay, because we only want a conveyor belt that can have conveyable items. We know a car part is conveyable because we implemented the convey trait right here for the car part. One last thing, since the conveyor belt is specific only to conveyable items, if we try to add something that's not conveyable to it, then we'll get a compiler error. So let's try that. So we have our conveyor belt, and we'll just try to add the number 5, and we'll do a cargo check and see what happens. So if we do cargo check, we'll get a message indicating that the convey trait is not implemented for an integer. So we try to add a 5. We can't because the trait convey is not implemented on that type. This concludes the demo on generic structures. I'll see you in the next presentation.